follow the 4 simple steps and reduce the cleaning time of a heat exchangers by 75%. It doesn't matter if your heat exchanger is 6 meters long and weighs 4 tons. What is required is looking into the processes which include the consumables or the cleaners that are used, the process that is followed, the machine that is used, and very importantly, time management. I am Chandrakant Tiwari, founder of Evergreen Solutions. While dealing with cleaning complex heat exchangers, you have to simultaneously look at the problem from 3 different angles. One is the MOC. You could have aluminum base or stainless steel base. The processes change. You could have types of contaminants, which could be scales, oils, greases, wax, and maybe some deposits of barium in water. That requires a totally different chemistry. And third is the resource available to you. If you have just a pressure washer or some chemistry or a tank. Now if you handle them differently, the time taken to clean will almost multiply. Today there are chemistries which can work on different sides at the same time. There are chemistries that can work on a surface to remove oils and greases, at the same time working on removing scales. Now this reduces the cleaning time. One other leverage that you could use is temperature. As you increase the temperature, the cleaning time comes down. And the third leverage that you could use is definitely ultrasonic machines. Because ultrasonic machines give you the ability to penetrate deep where finger or a brush or a wire cannot reach. So when you attack this problem from 3 different fronts, you have massive reduction in the total amount of cleaning time. Also remember, it is not just reduction of time, it is completeness of cleaning. You need to achieve 97 or at least 95% of heat exchange capacity. Now that can happen only when you have a combined system working together. And that's where some technologies come into the focus. Pulsonication. Now this is a technology that combines at least 4 different technologies. It uses special chemistries, it uses special ultrasonic frequencies, it uses certain power range which helps penetrate even the most stubborn of dirt, and importantly, it's a mechanized operation. When pulsonification goes on, at the end you have an opportunity to reduce the contaminant level down to an extent where the heat exchange capacity goes up to 95 or 97%. A heat exchanger with 97% or 95% is as good as new. When you reach those levels, there's a possibility that the energy cost comes down by about 15 to 20%. Now that's a huge saving. The second very important advantage is operational efficiency. Qualitative improvements are there when the heat exchanger is used using such, almost like when it's a new heat exchanger. And third, there's an absolute green process. The chemistries that we are talking about are all bio-based chemistries. They're all readily biodegradable products, and these can add to your carbon credits. So when you go in for a system like this, apart from the gains that are there in terms of the end product, which is your heat exchanger capacities, you also gain in various operational issues. If you know somebody who can be benefited by this kind of a technology, for whom in a power plant, in a refinery, in a pharmaceutical company, the energy requirements are far beyond what they had envisaged when they started the operations. Tag them in this video or share this particular video. I will see you in my next video.